Before we get into the software related aspect of a software TNC, we have to talk about some hardware considerations because there are hardware considerations. Notably, how you connect your computer to your radio. There are three things that have to be kept in mind with this. Number one is obvious that most people will immediately think about, and that's how to get from the back of your radio, your 2 meter radio, from the data port to the computer with regard to audio. So there's going to be a transmit and receive audio that's coming from the radio outward to your computer, right? And what people don't really consider is the fact that if you're going to be transmitting packet, you're going to have some sort of push to talk signaling. And that push to talk signaling is going to have to be sent to the radio to make the radio go into transmit mode to send the data when it's time for you to transmit. And there are a lot of cables out there where you'll see this connector that breaks out to a transmit and receive going to a computer. And you would think that's fine, but it is insufficient. Unless you have some sort of rig blaster and you're going to complicate this with, several different items to accomplish the transmit task, I would highly recommend getting something like this. And what this is simple. This is like I said, your connection to your radio, your transmit and receive to and from your computer. But what this connection also has is a USB interface here. And what this is a USB serial device that is actually in this box that does the signaling for push to talk, which meets all three requirements at once. So basically what you'd be doing is simply plugging this into the back of the radio, right? Connecting these to your speaker and microphone jacks of your sound card. And then this would go into your computer as a serial device whose primary function or sole function is push to talk. This particular box also has a nice feature because if you look in the middle here, during the push to talk activation, you get a red light. And I'm going to post the link to the location on eBay, and there's also a possibility on Amazon to order this device. And this particular one is for Yaesu. I have Yaesu radios. It's all I really own. So there might be a different interface for different types of radios, but we really have to discuss this because there are other options. There's a possibility of taking a 2 meter radio, something like this, and putting it on Vox mode and simply propping this up right next to the computer for transmit and receive. So you would have to be really quiet. Your mileage would vary with regard to the quality. For receive purposes, I imagine it would work okay, but for transmit, what you run into is the packet starts transmitting quicker than Vox starts turning on its transmit. So there are some complications with regard to that. So what we are going to use is the conventional connection to an actual radio. I know there's a million ways to do everything, but this is definitely the most stable and probably the highest quality that we're going to get, as opposed to just sticking a radio and propping it up next to your computer. Though we may try it just to see what happens. Another overlooked item is a sound card. While it may seem obvious that a laptop would have a microphone and speaker output built into it, you would have to consider the fact that if you're connecting it to a radio and you set something up wrong in a really bad way, that you could damage your laptop, and a laptop could be a $1,000 or more investment. What I did for experimentation is purchase a Sound Blaster USB sound card, and this cost about $30. I use this for all of my radio testing, my interfaces, especially on devices that are expensive, right? So if I do something wrong and I overdrive the input on this particular sound card and it blows up, I lost a $30 sound card. There are sound cards that are even cheaper. There are Chinese ones that cost $10, but I've heard some problems with them. But I wanted to point that out, that for the purpose of this video, what you're going to see is I'm actually going to be using a second sound device for connecting the computer to the radio, and that's going to be through this Sound Blaster sound card right here. What we have here is a brand new installation of Ubuntu GNOME 15.10. And all I've really done is change the browser to Google Chrome and add the software required to do these videos. What I want to talk about is the installation of Direwolf. And the first thing, obviously, that you should draw your attention to is the page. The link will be posted. And it might be a bit deceiving if you're not used to GitHub. You actually end up with what you would see here. And if you scroll down, there you will find the latest posted instructions. And there are really two ways to do this. You could download the file and do the installation, but you should probably start getting used to the Git clone, because there you have one single URL that you're downloading the latest and greatest from to compile against. And this is that command right there. It's quite simple. But before we do that, what we need to do is install Git, which should be on your distribution anyway. So you're going to do a sudo apt-get install Git. Type in your password. The next thing we have to do is install a dependency that is required to get Direwolf to compile. So let me get out of this. So what you would type in is sudo apt-get install libasound2-dev. Once that's complete, we could then go to our home directory. And what we're going to do is we're going to use Git to bring the latest source of Direwolf into a directory called Direwolf, right? So we're in our home directory. We paste that in, and we wait for the source code to be downloaded to the directory. Once the download is done, we'll cd to Direwolf, right? We can see all the contents are in there, and we'll just type make. Now, as the instruction states, sudo make install, and finally make install.conf. I'm sorry, make install-conf. And we can see what was done with that last piece to get our configuration files moved into the home directory, right? This later one has an sdr.conf. I haven't really played with that yet, but there's also some further things for Raspberry Pi that we're not going to deal with in this particular video. One of the problems that we face with the push-to-talk is the fact that the way Linux assigns USB serial devices. And one of the things that we run into is when you connect a USB serial device and you plug it in, as I do now, and we take a look with DMESG, we see that the device is attached to TTY USB 0. Now, this may seem okay as we go through our configuration in Direwolf and tell it that the push-to-talk device is dev TTY USB 0. The problem is in your computer you may have more than one USB serial device, and depending on which order it was plugged in, this may in fact become dev TTY USB 1. This is a problem in Linux. Well, not so much of a problem, but something that people have to keep in mind is the locking down of USB devices. So what we're really looking for is that our USB device will always be dev PTT, no matter what order it was plugged into. And the way we do this is first have an understanding of what it is we plugged in. And we can see that we have some information right here that the USB device was plugged in, and this is the vendor, and this is the product, the manufacturer, and the serial number, which unfortunately in this case is 0, but it's not a major issue. And what we have to do is we have to create a rule for USB that when we meet all of these requirements with the vendor, product, manufacturer, product number, and serial number, that instead of simply calling that device TTY USB 0, we're going to call that device dev PTT. And that's what we're going to try and accomplish right now. So we have our device plugged in. We have the information about it. You can also see the information running a LS-USB. If you wanted to, it's not going to provide the same depth of information. The other option is a LS-USB -VV, which will really provide you anything you've ever wanted to know about your particular device, right? But since the things that we are looking for are already posted in DMESG, we have basically what we need to accomplish this task. So we go back to DMESG, we take a look, and now we have to write a persistence file. We have to create a rule in Linux that when USB devices come in, they're checked for that rule, and then they're assigned a symbolic link that we will name, in our case, PTT. So let's do that now. So we're going to open up another window, and the reason is so we could have the data we're looking for here below while we work with the file that we're going to add to allow this to automatically happen. And what we're going to do is we're going to go, first of all, we're going to sudo -s, so we're root. And we're going to go to cd/etc udev rules D. And that's the directory we're going to be in. I've already created this file, so everybody doesn't have to watch me type it in. But if I look, we'll see a file called 99-usb-serial.rules. And if we look at this file that I've created, and you should create the very same file, we're going to see very quickly that we have subsystem is TTY, and we're going to set some attributes, and the attributes are what we're going to try and match to assign our symbolic link. So we looked here and we saw our ID vendor, and we make that an attribute, just like this, followed by a comma, and then we have our ID product. We can see here is 2303, and we did that as well. Also, because our serial number happens to be serial 0, we create another attribute serial with 0, followed by another comma. And then what we say is, when we match all of that criteria, we should call the symbolic link PTT. And in this way, it will appear in the dev directory as /dev/PTT whenever you plug in this particular device, right? So once you have that filled out exactly as I've shown, and be sure that you're using the correct equal signs here and the correct, just be very careful as you type this in that you don't make any errors or it's not going to work. When you're finished, hit Control O. We can assign that name that we're describing earlier, 99 USB serial rules, and then Control X. And then we just take a look and make sure it's there, right? And there it is. Now what we're going to do is go to etc init.d to restart our USB services, our UDEV services. And I'm going to unplug the serial device, right? And I'm going to go udev restart, right? It says udev is restarted. So now I'm going to plug the serial device back in and go back to our other window here and do a DMESG. It doesn't look any different. We could see that we had since disconnected and reconnected that device. But if I go to the dev directory, right, and I do an ls ptt, we can see that there's PTT right there. It automatically appeared. Let's do an LSL to see what constructed this. And you can see that Linux found this particular device, which was TTY USB 0, it read our rules and then assigned it as a link to another file called PTT. So what we ended up with is dev PTT. Now, when we plug this particular USB cable into the computer, always and forever now, all we'll have to do is set our configuration for push to talk. When it asks for a push to talk value, we're just going to put dev PTT in any one of those things. And you can use this for, not just for Direwolf, but for any program that has push to talk in Linux, such as FLDigi or what have you. If you're connecting this particular device to FLDigi, you'll use dev PTT for that physical cable that you're plugging in. Before we get into the configurations of Direwolf, and what we're going to configure in this interval is simply the audio, we need to find out what our audio device is. And this is really simple in Linux. What we're going to do is do a play -L, right? And we see my Sound Blaster card, and focus right here. We got card 1, device 0. So subsequently for record, we could do a record -L. We also see that the input is also card 1, device 0. And this is great because now we can go to direwolf.conf, right? And we scroll down to a particular line, and this is just to get us going. And I've already removed the remark on mine, okay? You'll see this line right here, which is line 69, tells it what the audio device is going to be for the first audio device, right? So we're talking about channel 0, okay? And as we saw, for both of them, card 1, device 0, we're going to do plug hardware 1 0. That's all there is. There's nothing else to do but set that up. If your device was card 2 0, then it would be 2 0. If it was 2 1, then it would be 2 1. Generally, for our purposes, the playback and the record device is going to be the same device, and we just need those two values to populate this, and you're finished. So you hit Control-O after you make the changes, Control-X, and then it's saved. That's all there is to the assignment of an audio device. This is not setting up the levels. This is simply the assignment of the audio device. So I turn up the radio volume a little bit so you could hear the APRS traffic on 144.39. We've got one change made in the configuration, and that's what our audio device is. I have the cable, the data cable, plugged in the back of the radio now. The data cable that was discussed earlier. It's going into the sound card we just configured and into the computer. So let's see if this works. So we're just going to run Direwolf for that one change, right? And we immediately see packet traffic is flowing. We have our channel 0 we set up, right? It's got the sampling rate already from 1 0. Audio device for both transmit and receive, right? And what we're doing right now, we're not getting too deep into it. We're simply looking to see that we're getting packet traffic. I'll immediately point out that if you look at the audio levels, they're absolutely ridiculous, right? They should be around 50. They should average around 50, and they're 187. But the goal here was just to see if it works. And we see that it does work, and now we can continue on. So what do we do about these really high audio levels? Well, the first thing I want to do is I'm going to adjust those levels for the input and also mixer. But I want to do it as root so that whatever changes I make are applied and stay for the entire session. Right? You can also do sudo also mixer. This is the same thing. Now, we have to select which sound card because by default it's showing the sound card that's built into my computer. As you see here, we hit F6, we choose our Sound Blaster, and then we hit F5 to show all possible configurations. It's a very simple sound card, so all we have basically is our input and output. And as we look at the packet traffic, as I will attempt to do here, we're going to capture, and we're going to drop it down slightly. 1 or 2 clicks, and we're going to look at the audio levels. We're still seeing that they're high. I continue to lower it. Now down to 55. Of course, we have no packet traffic at this exact moment. There we go. And we see our audio levels are dropping. Now I'm down to 92. It's under 100 now, which is within tolerance. Again, I dropped it. It's down to 86. 86, 87. Hit it again. The roll-off in gain is substantial. So once you start getting it close, you're going to see that one single drop will bring them down significantly. We're at 74. I'll tell you what, I'll hit it one more time. Down to 50. It would be ironic if 50 had an audio level of 50. We'll see what we get. Yes, we're seeing 74. It's not a perfect science, but you want to get it around 50. 74 is absolutely fine. It's definitely not too big, right? And then we hit escape. And now we have the audio levels that we want. We're no longer getting that error or warning, and we can continue safely. So now we're back at the prompt. We've got the audio levels that we want. So all we need to do is type ALSA CTL store. And this will store all of our ALSA configurations for subsequent boot ups. It won't be lost. And we won't have to keep adjusting those settings again. I'll remind you that if you do go into ALSA Mixer and make those changes, you'll have to run ALSA control store again to ensure that the current state of those ALSA settings are stored. Since we're going to be running Direwolf as a user and not as root, we're going to have to make a permission change for the particular user that's going to be take advantage of the push-to-talk serial interface. If you attempt to simply change a config in Direwolf, you're going to get a permissions error. So what we do very simply is sudo usermod -a -G dial out followed by the name of the user, in my case Jordan. We do that and we will have that permission fixed. In order for that account to be able to take advantage of that new group which it was added to, you're going to have to log out and log back in on the computer. So if you attempt to immediately make that change and take advantage of it, the permission error will persist. So we're going to log out and log back in. Now that we've logged back in, we're going to make another change into the Direwolf config that allows push-to-talk to work. If I run Direwolf right now, you'll see that we have a note that push-to-talk is not configured. I'm going to exit out, and I'm going to go to our config file. Go to line 185 if you don't feel like scrolling down, and we're going to enable this particular line. Now you could keep it TTY USB 0 if you're not using the persistence link that was specified earlier, but I'm using it, and it's going to be dev PTT. If you're using Vox and none of this and holding your radio up to your computer, obviously you're not going to be doing any of this, but all of my applications that use that particular cable will use dev PTT. I hit Control O and I save. I hit Control X to exit, and now we're going to run Direwolf again, and we'll see that we no longer have that line that says that PTT is not configured. So what we have right now is our audio device is set up, like, you know, because we're receiving packets. What it's set up for, as default, happens to work with APRS, and we have our client application ports is how it's set up for by default. So we have everything we need with push-to-talk and everything else. At this point, we could, in fact, install Xastir and see that work with transmit and receive. At this point, we could simply just run Direwolf and keep it running in the background. I should point out that for applications that require a serial TNC connection, there is an option with -P when you start it. And it's as simple as that. So there is a warning there, but it wants to let you know that for devices that can take advantage of using a particular port, as Direwolf does by default, right, that you can use temp TNC as what would appear to be, from the perspective of the program, the serial interface that you would use to connect to this TNC as a KISS TNC, right? So I wanted to point that part out first. We're going to go back into our Direwolf config. I'm going to make this big so it's easier to see, right? And what you want to do, like all ham radio applications, first and foremost, and most importantly, is change your call sign to your actual call sign. I can't stress that enough. My call is not a valid call sign. And we go down through the configuration. This was our audio config. And it says my call is no call. And I'm going to change it to my call. Change it to your call, not my call. So KJ4TLB, and we're going to call this test event, we're going to call this 5, right? Control O to save. So now I at least have a valid call sign for station identification using our 1200 baud modem as configured by default, right? And we have our push to talk in. We really have at this point everything we need to do APRS on Xastir, because no further configuration changes are required within this file, right? We saw here that our AGW TCP ports are by default 8000 and 8001, right? And those changes we haven't made, those are simply by default. And we'll see that later depending on how we want to configure Xastir. And we're not turning on any beaconing or anything within Direwolf itself. Obviously, we'd have a client that would do beaconing. This is just to show you that it's supported. I'm not changing anything. We changed push to talk to call sign and the audio device, and that was it, right? So I'll make the screen small again. And now we're kind of safe at this point to run Direwolf. I'll run it with the -P, so we do have both options. And now we install Xastir. So we do a sudo apt get install Xastir. Type in our password. And like I said, Direwolf just kind of runs in the background. This is going to take a bit, so I'll probably speed this portion up so we don't have to sit through and watch the Xastir installation. During the course of this installation, you'll see this message. This might apply to some depending on how you're running it, or if you're using the AX25 stack. But it's good to know that you should take heed when reading this to know what happens if you're running something directly as root or not as root, and what the differences could be with regard to that. So I hit OK. And this is kind of your choice. If you want non-root users to be able to access AX25 interfaces, you would choose yes. My user is not a root user. I'm just going to say yes because this laptop is for testing. I don't have any security issues that I'm really worried about for APRS. Right? So I make that choice and we continue on with our installation of Xastir. We can see that Xastir is installed and it's in the Xastir AX25 group. So we're going to have to add the user, in this case me, to that group to be able to use the Xastir software. So we're going to do a sudo usermod -a -g Xastir-AX25 Jordan. And now we've added myself to the group. Most likely we're going to have to log out and log back in order for this to take effect. So now we've logged back in. Let's start our Direwolf, and we'll use the -P option just so we have the TNC available to us. We're just going to place that right there. And I'm going to open up another terminal window, just because I haven't created an icon yet, or looked as to where it is. And we're going to start Xastir. And you should be able to run Xastir as your local user after you made that last change. Right? So Xastir opens up, and it immediately will ask you for some information. I'm not going to get too deep into configuring Xastir, but I will as much say that our call sign is KJ4TLB-5. I'm not going to put in my latitude and longitude right now. We could say that our radio information is that with this high with an omnidirectional antenna, and we're not going to worry about ambiguity, right? So I click OK. And we're going to make the screen a bit bigger so we can see it. I'm going to zoom in. Okay. So related to Direwolf, we go to interface control, and we want to add one. And we have two available to us right now, right? Because we have our serial KISS TNC, as well as our other port, our AX25 port that we were using before. So let's do serial KISS TNC since we did the -P option. We're going to hit add, and it's going to ask us what the port is. And if we looked at Direwolf before, you will see that it was temp KISS TNC, right? So there it is right there, and that's the TNC that it's looking for. So we do /TMP/KISS TNC. I'll say that it runs at 19.2, and we're not going to change any other configurations right now. We're just trying to get up and running. So hit OK, select it, and hit start. And we can see that TNC is up and running right now. All right. So I'm going to close this out, and we're going to take a look at the map. And we're going to see that information is starting to appear in Florida. Let's look at the message traffic. These are incoming data. Let's turn up the radio a bit so we can get some context as to what's going on. Maybe too high. So we can see that the receive portion, it's still too high. We can see that the receive portion of Xastir is working. And while I do not have the correct coordinates in the computer right now, and I'm somewhere in the middle of the Atlantic Ocean, what I'm going to do is transmit my information. And we can see that my information has gone out over the radio. So what I found was, even though I'm sending packets, because I don't have any real data, it's actually not getting out onto the network for this call sign, KJ4TLB5. So I am going to take the time. I did put in my latitude and longitude. I've assigned it the old school X windows, and added a little comment here. So now I have that set up. So when I hit OK, you're going to see that I'm actually in the correct location. We're going to check our interface. And we see our interface is up and running. And what I'm going to do is I'm going to transmit. And it's APRS. So basically what's going to happen is I'm going to let it sit here for a while and be discovered. And then we're going to come back, and then we're going to look at the APRS.FI and see if I was found. We know we're seeing everybody else. The question is now, can they see me? But what I'm going to do, since I'm already in here, is I'm going to the configuration, in the correct configuration, and I'm going to edit this slightly and I'm going to allow for digipeating, and I'm going to allow for internet traffic inbound and outbound to this particular radio. So that's the only thing I wanted to add here to make sure that it increases our visibility on APRS. So I'll close that out, and then we're going to come back in a little while and we're going to have a look. I should also point out that if you don't want to use the -P option, right, you can even just make this go away. We can delete that. The other option is the default port on 8000. When we looked at Direwolf come up, as you know, it pointed out to us that 8000 was available to us. So what I'm going to do is do an add, right, networked AGWPE. When I open this up, it already has a default port of 8000. I'll just add that in there and click OK and click Start. And this port also works for Direwolf. Like I said, we had two options available to us. So I close, and if I hit Interface and Transmit, I could then transmit out, and functions exactly the same, except it doesn't have digipeating as an option available to it, right? So we could see how using KISS TNC affords us some more options, right? So I'm going to close this out, right? And I'm going to stop Direwolf. And I'm going to run Direwolf without the -P. So now we only have, this is in its most default form, only ports 8000 and 8001. And then I'm going to reload Xastir. We check our interface, and we see that we are up on that. And you can see that it is working in the very same fashion. So that's the other option, probably the easiest option in configuring it, but you do lose the digipeater ability, right? So that covers now both ways that you could use Direwolf to interface with Xastir. So now it's been running for a little while, and I typed in the call sign KJ4TLB-5, and we can see that I'm finally posting on APRS, and you can see my location. This one is delineated with the X logo and the message that we put in, running Xastir on Linux 15.10 Direwolf on Ubuntu. And now if I look at station info, we can see that the stations that are near me, and more importantly, for the purpose of this demonstration, stations who actually heard me on the radio. And this guy's a big player in the area. This is just an enormous station. But it shows that the packets that's been transmitting for APRS has gone through Direwolf to the radio over the air and was received by this station and then posted onto APRS.fi. So this is APRS working on Direwolf using Xastir from beginning to end. There are other programs that you can use like Yak for APRS as well, and that could be a separate video that latches onto where we are now on this video. But this concludes the presentation of Direwolf running APRS. Thanks for watching.